welcome back. Ready for another deep dive?
Always.
Today we're going to be looking at, this super interesting article from Live Science. It's about a new material. It was just published January 31st of this year, 2025.
Oh, wow. So just came out.
Yeah.
Nice.
It's called New Wonder Material designed by AI is as light as foam, but as strong as steel. And I mean, that title pretty much sums it up, right?
Yeah, that's pretty amazing.
Like, how is that even possible?
That sounds like something straight out of science fiction.
I know, right? But the article talks about how researchers are actually using AI and 3D printing to create these materials that have the strength of steel, but they're incredibly lightweight, like styrofoam.
That's fascinating. I mean, think about the implications of that, like lighter cars, planes.
Oh, yeah, I was going to say that.
Yeah.
Like, imagine, what that could mean for fuel efficiency and the environment.
Absolutely. Less weight means less fuel consumption, which is a huge win for sustainability.
Okay, so I know this material is like super strong and super light, but how does it actually work? The article mentions nanomaterials. I know those are like super tiny, right?
Yeah, they're incredibly small, like on the scale of atoms and molecules.
So how do they get around that?
Get around what?
Like the problem of being strong, but also super brittle.
Ah, yeah, that's the classic strength-toughness paradox.
Okay, hold on. Can you explain that a little bit more?
Sure. So think about a ceramic plate.
Yeah.
Okay?
Yep.
It's very strong. It can hold a lot of weight, but if you drop it, it shatters easily.
Yeah, because it's brittle.
Exactly. It lacks toughness, which is the ability to resist fracture.
Okay, I'm following you. So where do nanomaterials fit into all of this?
Well, nanomaterials face a similar problem. They're strong at the nanoscale, but they can be brittle too. Like they can shatter under stress because of these things called stress concentrations.
Stress concentrations. Okay, I'm lost again.
It's kind of like, imagine you have a piece of paper and you make a tiny little tear in it. If you pull on the paper, it's likely to rip right at that tear because the force is concentrated at that point.
Oh, I see. So it's like a weak spot.
Yeah, exactly. And that's what happens with nanomaterials. These tiny imperfections can act as stress concentrators and cause the material to fail.
So how did they fix that?
Well, that's where the AI comes in.
Oh, okay. I was wondering when we were going to get back to the AI part.
So the researchers basically used machine learning. They simulated all these different geometries of nanomaterials.
Wait, so they fed the AI a bunch of different designs?
Yeah, and they let the AI learn which designs were best at distributing stress and carrying loads.
So instead of just trying to randomly test out different designs themselves, they let the AI figure it out.
Exactly. They basically outsourced the problem to the AI, which is way faster and more efficient than trial and error.
So what happened? Did the AI just copy the best existing designs?
Nope. That's the really cool part. The AI didn't just copy. It came up with entirely new geometries, like shapes that humans hadn't even thought of before.
No way. So the AI was like, hey, humans, check this out. I've got a better way to build this.
That's a great way to put it.
So what were the results like?
The results were pretty astounding. This material is, get this, 5 times stronger than titanium.
Wow, titanium is like the gold standard for strong, lightweight materials, right?
Exactly. And not only is it stronger, but it can also withstand incredible levels of stress.
Like how much stress are we talking about?
Well, the article says it can withstand a stress level of 2.03 megapascals.
2.03 megawatt.
Megapascals.
Yeah.
It's a unit of pressure. It basically measures how much force the material can withstand per unit of weight.
Okay, I'm still a little fuzzy on that, but it sounds like a lot.
It is, trust me. It's like, imagine a feather being able to support the weight of a car.
Whoa, that's one strong feather.
Right. So you can see why this material has such huge potential for real-world applications.
No kidding. So this isn't just some lab experiment then.
Definitely not. The article specifically mentions the aerospace and automotive industries.
Yeah, well, that makes sense. Imagine how much fuel you could save if planes were made with this stuff.
Exactly. The article says that for airplanes, replacing just 1 kilogram of titanium with this new material could save 80 liters of fuel per year.
80 liters per year, per kilogram. That's insane.
Now imagine that scaled up to an entire fleet of aircraft.
We're talking about a massive reduction in fuel costs and carbon emissions.
Absolutely. And it's not just airplanes either.
Yeah.
Cars, trucks, even spacecraft could all benefit from this.
Yeah, any application where weight is a factor, right?
Exactly. Lighter materials mean better performance, lower costs, and a smaller environmental footprint.
Okay, so before we get too carried away with all the possibilities, I'm curious about the manufacturing process. Like, is it even feasible to produce this stuff on a large scale?
Well, that's the million-dollar question, isn't it?
Yeah.
The article mentions they've been able to create small samples using 3D printing.
3D printing.
Yeah,
Okay, that makes sense, I guess. To build something that intricate at the nanoscale, you'd need that level of precision, right?
yeah, exactly. 3D printing allows you to build these complex structures layer by layer.
But isn't scaling that up, like to mass production, still a pretty big hurdle?
Yeah, for sure. It's not just about making things bigger, it's also about maintaining that same level of precision and quality control when you're producing large quantities.
And I imagine the cost is a factor too, right? Like 3D printing can be pretty expensive, especially when you're talking about specialized materials.
Yeah, absolutely. Cost is definitely a major consideration. If this material is going to be widely adopted, it needs to be affordable to produce.
Right. Well, I mean, that's always the case with new technologies, right? Like as the production methods improve and economies of scale kick in, the costs tend to come down.
Exactly.
Like, think about solar panels. They used to be so expensive, but now they're becoming more and more accessible every day.
Yeah, great point.
So I guess while there are definitely challenges to overcome in terms of manufacturing, I mean, we shouldn't rule this material out just yet.
I definitely wouldn't. I think it has enormous potential.
Okay, so let's say we can overcome those challenges and we can actually start producing this stuff in large quantities. Like, where do you see the biggest impact happening first?
Well, the article, like we've been talking about, focuses on aerospace and automotive, but I think the potential applications go way beyond that. Like, for example, imagine using this material in construction.
Oh, yeah. You could build lighter, stronger structures that are more resistant to things like earthquakes, natural
Yeah.
disasters.
Yeah, exactly. And not just, new construction. Think about retrofitting existing buildings or bridges to make them safer and more resilient.
Right.
And then there's the medical field.
Oh, wow.
Imagine lightweight, biocompatible implants
Okay, now you're talking.
that are strong enough to withstand the stresses of everyday life.
Yeah, I'm thinking like prosthetic limbs that are more comfortable and functional, or even tiny implantable devices that can monitor our health in real time.
Yeah. The possibilities are really kind of endless.
This is amazing.
And, the fact that this material was designed by AI, well, that means, we're not limited by our own human biases or, preconceived notions about what's possible.
Right.
Like the AI can explore this vast design space that we could never fully comprehend on our own.
So it's almost like having a million engineers, working around the clock, coming up with these new innovative solutions.
Yeah, a great analogy.
I mean, it really makes you wonder, like, what other breakthroughs are just waiting to be discovered?
It's exciting to think about.
Yeah, it's exciting, but it's also like a little bit daunting, isn't it?
What do you mean?
Like, if AI can design materials that are this revolutionary, what does that mean for like the future of human ingenuity?
Hmm. That's an interesting question. I don't think it means human ingenuity is becoming obsolete.
Okay.
In fact, I think it's quite the opposite.
Okay.
I see AI as a tool. It's a tool that can augment our own creativity and our problem-solving abilities.
So it's not about AI replacing us, it's about AI empowering us to do things we couldn't do before.
Exactly.
Yeah.
And it's not just about designing new materials. AI can also help us to optimize existing materials, find new ways to manufacture them more efficiently, and even predict, how they'll perform under different conditions.
So it's like having this super powered lab assistant
Yeah,
that can help us push the boundaries of what's possible in material science.
I like that. Yeah, that's a great analogy.
Thanks.
And just like any good lab assistant, AI can help us to gather data, analyze results, and test hypotheses way faster than we ever could on our own.
Which means like we can focus on, the bigger picture,
Yeah,
asking those really big questions and coming up with truly groundbreaking ideas.
I like the way you think. And that brings me to something I've been pondering as we've been talking about this new material. We've talked about, the practical applications.
Right.
But what about the more imaginative possibilities?
Oh, ooh, okay. Like what?
Like, what if we could design a material that could actually heal itself, like living tissue,
Ooh.
or a material that could change its properties on demand?
Okay, now you're talking like science fiction.
I know, right? But who knows? Maybe with AI as our partner, those seemingly impossible ideas could one day become reality.
Yeah, it's like we're on the verge of this like material revolution where the
Yeah.
very building blocks of our world are becoming like smarter, more adaptable, maybe even a little bit
A
magical.
material revolution. I like that. And it's all thanks to, this incredible synergy between AI, material science, and these advanced manufacturing techniques like 3D printing.
Oh, speaking of 3D printing, I was kind of curious about how that plays into all this. Seems like it would be pretty essential for like creating these complex geometries that, that the AI is dreaming up.
Yeah, it's absolutely essential. Traditional manufacturing methods they're often pretty limited in terms of the shapes and structures they can create. But with 3D printing, we can essentially build things layer by layer. So we can, create almost any geometry we can imagine.
So it's like having a 3D printer that can build things at like the nanoscale.
Exactly. Which opens up this whole new world of possibilities for material design. We're not constrained by those limitations of traditional manufacturing anymore.
I bet that's like pretty exciting for material scientists and engineers.
It is. It's like the difference between like drawing a picture with crayons and having, a full-fledged digital art studio at your fingertips.
So where do you see all this heading in the future? What kind of like crazy sci-fi materials might we be seeing, I don't know, 10, 20, even 50 years down the road?
Well, it's hard to say for sure, but I think we can safely say the future of materials is going to be incredibly dynamic and exciting. Imagine materials that can, change color or shape on demand, or materials that can repair themselves, like living tissue.
Or maybe even materials that can like interact with our bodies in new ways, like clothing that can monitor our vital signs or deliver medication.
Yeah, those are great ideas. And who knows, maybe we'll even see materials that can harness energy from their surroundings, like solar panels woven into the fabric of buildings or even clothing.
It's like the line between science fiction and reality is starting to blur.
It really is. And I think that's one of the most exciting things about this field.
Mm.
The possibilities are truly limitless.
So for all you budding scientists and engineers and dreamers out there, this is your call to action. The future of materials is wide open. It's up to you to shape it.
Well said. We need, curious minds, bold ideas, a willingness to push the boundaries of what's possible.
Who knows? Maybe one day we'll be doing a deep dive into your groundbreaking discovery. But until then, keep exploring, keep innovating, and keep dreaming big.
And remember, if a material as light as foam, but as strong as steel was once considered impossible, I mean, what other seemingly impossible dreams can we dare to chase?
Right. That's all the time we have for today's deep dive, but I hope this has sparked your imagination and left you feeling inspired about the future of materials. And make sure to check out the show notes for a link to the full Life Science article if you want to explore this topic even further.
Until next time, keep questioning, keep learning, and keep pushing the boundaries of human knowledge.